good stuff, right? Okay. I am Lochemem Bruno Michael. If you want to reach out to me, you can contact me via my website,2m.site. It's right there. You can hit me up on Twitter. You can get at me on on GitHub. If you want to collaborate on anything, like on any projects, just contact me. Right. So who am I? Right. I am a PHP, JavaScript, and C++ enthusiast. I like all three languages. I recently got into V, which is another low-level language. Pretty interesting project. I am a functional programming aficionado. I really love functional programming. I've been enamored of the paradigm since the first time I read Cakes, Custard, and Category Theory. My talk from last year which is titled Functional Programming in PHP. This is pretty much a showcase of this section that I have for the paradigm. So you might want to check that out. It's actually on the PHP Conference YouTube channel. I maintain several packages and PHP extensions. Some you might have used, some you might not have used. The most notable ones are my functional programming library. I have a try extension, if you're familiar with the try data structure. I wrote and I continue to maintain a JWT Jose extension. So you can check all those out. They're on GitHub. I have also written a book titled Functional Programming in PHP. So you might want to check that out. It's retailing on LeanPub for $9.99. I'm a hooper. So in my free time, I like to, get buckets. Right. Yeah, shout out to Hoop Squad. And also I play video games. So yeah. Currently playing Ghost of Tsushima, Iki Island. I got the Iki Island expansion last week. And so yeah, playing through. Right. Okay, so so we'll get to serious business now. All right, so a lot of usable software is a combination of input-output operations, right? So a lot of the software that we write is a metastable combination of input-output routines, right? So you're either reading from a file, writing to a file, reading from a database, writing to a database, that type of thing. Reading from standard input, printing out to standard output, API calls galore, you're trying to call this service and that service, that type of thing. That typifies, the programming experience for a lot of developers, not just PHP developers, but really for a lot of developers and engineers, right? But the problem with IO is that it is really, really, really slow, right? IO is very arduous. Now, to put that into context, right, we will look at, memory acts. We'll look at latency, right, which is pretty much a measure of dormancy, right? CPU dormancy. So we'll look at, the L1 cache, which is at the very apex of, memory hierarchy, and, sending packets, cross borders, which is a lot closer to the bottom of the memory hierarchy. And you can see the difference in the latency, right? You can get this stuff from latency numbers every programmer should know, right? Now, what's really interesting about this is as programmers, as developers, as engineers, we operate in that tier, close to the bottom tier with all these, IO operations, right? We operate close to, the bottom tier. And the fun fact is if you multiply the durations by a billion, the latency in nanoseconds by a billion is accessing data from the L1 cache is, well, the speed of access is equivalent to, a single heartbeat. But, sending a packet from California to Holland and back to California, basically all these different hops would extrapolate to an entire bachelor's degree program, which is about 4 years, right? So yeah, this is all, these numbers you can find on, latency numbers every programmer should know. You can find it on, You can find it in that gist, right? There's a gist. So traditional PHP is, despite recent improvements, not immune to this problem. So like I said, there's a universality of this arduousness, this strenuousness of IO, and PHP is not immune to it, right? So what you get in PHP is a lot of blocking IO, a lot of blocking code. So you have to, typically without any asynchronous capability, you have to, whenever you chain function calls, is you have to wait between successive executions, right? So in this case, if you look at the snippet on the right side, you'll see a function that is essentially calls, pulls data from some API somewhere, right? And you'll see calls, you'll see invocations of that function. Now I've wrapped it inside of an IO instance, and so all my functional programming aficionados will be familiar with the IO monad. But yeah, but essentially, you get a lot of blocking IO. You get a lot of you have a lot of these sequential calls in non-asynchronous PHP, which is a lot of conventional PHP, and you bind the results of every invocation of the function directly to a variable. So first, move on. So the results of a call to say Google will be bound to the variable first, and a call to something else, perhaps a LinkedIn API or a Facebook API, right, will be bound to the variable you can call second, right? Is that type of workflow defines traditional PHP, right? And now when you look at the conventional HTTP configuration of PHP, is you have a client, in this case, a user accessing your service via a web browser, right? Getting your data from, accessing data served from a PHP script via Apache, right? They don't really see the Apache connection, but in traditional LAMP stacks is you have Apache and mod PHP serving, interpreting PHP files and serving PHP assets, which will then allow the client, the user on the other end, to view the contents of your database, the contents of essentially the contents that you intend to convey in your PHP script, right? So this defines a lot of LAMP stack technology, right? And you can tune this up with PHP FPM, right? The fast process manager, which essentially spawns multiple threads, PHP threads to give your application more potency, right? Still works, right? So I mean, you can't complain. It gets the job done. PHP gets the job done. This LAMP stack still suffices. You can replace Apache with Nginx. Use a reverse proxy. You can get really creative with that. Yeah, like I said, it still works. But input output has only gotten more arduous. You can argue it's only gotten more strenuous. Now there's a greater need. There's greater clamor for live data, right? You have server-sent events, which is essentially live server updates served over HTTP, right? You have more robust HTTP APIs, capable of meeting both needs, both kinds of needs, and you have many more input output, many more advances in input output, right? Now, asynchrony is a great answer to these problems. Again, it doesn't take away all the latency. It doesn't completely eliminate the arduousness of IO, because like I said, a lot of software that we write is metastable. We're working in a state I'd like to describe as a shaky equilibrium, as programmers. Anything could break at any moment. In production, a lot of things could happen, right? Yeah, that type of thing. So yeah, asynchrony is a potent answer. So what is it? I mean, what is asynchronous? Someone might ask you, hey, define asynchrony, right? So it's the ability to run multiple processes independent of main program flow by interleaving them in a single execution thread. So you have a single execution context, right? And you have some sort of dispatcher, quasi-scheduler, event watcher at the center of it, right? And it listens for all these different events. Hey, I want to read from this file. I want to write to that file. I want to read from this database. I want to write to that database, specifically to some table somewhere, right? That type of thing. That's what asynchrony is. And so what are the requirements, right? You have an event loop, which is that dispatcher, that scheduler, that watcher, right? Quintessential component, very important. And then you have a proxy mechanism for handling these undetermined values, right? So the values yet to be computed, in these callback action chains, right? So listen for events, dispatch handlers to these events. Okay, now do something with that data. You need a proxy mechanism for handling that data that is yet to be determined, right? And then you need a lot of unbuffered data because you don't want any transient storage. You don't want any of that, right? And you need a single threaded runtime. Now, usually when you think about non-blocking IO, you think about Node.js. Hey, just write it in Node, right? Is what some people might say is, hey, you want to do something non-blocking, just write it in Node. It's all the way asynchronous, built atop Google's V8 engine, and it's pretty popular, right? But the thing is, PHP is well suited to the needs of asynchrony, right? And it doesn't offer it out of the box. It doesn't offer it as a default feature, right? So you were to get an asynchronous PHP landscape, to essentially get asynchrony in PHP. To achieve asynchrony in PHP, well, you need some additional plumbing, right? Now, if you paid any attention to what I said before, if you pay attention to any of the antecedent material, you'll realize that PHP has PHP meets you can get the requirements for running asynchronous code in PHP. Like you can get all the requirements in PHP, so you don't necessarily need Node, right? And when you look at the asynchronous PHP landscape, you have ReactPHP, which looks a lot like Node.js, as you'll see later in the talk. And then you have AMP, you might have heard of it. Looks a lot like Go. It's a combination of Go and Node.js, simply because you have event loop, and you have already you have the stylistic resemblances with Node promises and whatnot. But also you have code routines and AMP. Same for Swool, right? And I believe there's a talk that came before mine that was focused on Swool. So Swool is another package, but that's served via PECL. So you have to install it as an extension. You have to install the extension via PECL. So yeah. Now, a lot of the material in my talk is centered around conveying these asynchronous principles of ReactPHP. So ReactPHP is essentially what I chose to focus on with this talk, and it is the original React because it came before React.js. React.js is a front-end library for building robust user interfaces. This is a suite of asynchronous technologies for PHP. It came before React.js, and that's something a lot of people might not know. So this is the original ReactPHP. So what is it, right? Like I said, it's a suite of packages based on the Reactor pattern intended to enable event-driven programming in PHP. So React is, like I said, React is just a set of these technologies, right? Whose purpose is to make asynchronous programming or event-driven programming in reality in PHP, right? And so it comes in event loop, a stream abstraction, an HTTP client and server, child processes, and many more components. You can check out the React website. Right. So at the core of many event-driven systems is the event loop. So the quintessential non-blocking IO component is the event loop. The quintessential event-driven component is the event loop, right? So what is it? It is a quasi-scheduler, because with the event loop, you're able to defer the execution of tasks, right? You can manually do that. It is essentially an artifact that monitors your execution context, usually this single-threaded runtime for events, right? So, like I said, it is this watcher that essentially dispatches, dispatches handlers, which are these callbacks, to these events. Okay, I want to read from this file. I want to, write to that file. I want to, read something from standard input, pipe it out to standard output. That type of thing is the event listener, or rather the event loop will listen for all of that, right? And it can be written in idiomatic PHP. So you don't necessarily need an embellishment. You don't need an extension. You don't need any, you don't really need any additional code beyond outside of, userland PHP to implement an event loop. Now, what you see on the right side of the screen is the snippet on the right side of the screen is pseudocode for a primitive event loop in PHP, and this works for only 1,024 file descriptors. What a file descriptor is essentially just a unique identifier for the socket, a file, file handler, like that type of thing, right? That's what a file descriptor is essentially, and basically what an event loop does is, like I said, listen for your read events and your write events, and you pipe all of those into the stream select function and dispatch every action. You rather dispatch a handler to handle every action that comes in, right? Each of these events, right? Okay, so now for something practical, a practical event loop. Now, I started this, I prefaced this by showing how to install the ReactPHP event loop. And this is pretty much how you'd implement it, right? To write something that approximates to the JavaScript set interval function, right? If you've used JavaScript before, you might be familiar with set interval. Basically allows you to do something after a specified period of time, right? Do something repetitively after a specified interval of time, right? So what the event loop does is, like I said, listens for events and dispatches actions to process them. It renders everything in its context non-blocking. Now, originally, the old React standard is, well, it's still valid today. You can still use it today. But the old standard, you have to use the factory create method and then invoke the run method at the very bottom of your entry script. You don't necessarily need to do that anymore because of a default loop. So now you're operating in a way that is similar to just working with Node.js, right? There's libuv underneath everything, right? And we'll talk about that in a bit, but there's an event loop inside of Node.js, but you don't explicitly call it, right? You don't necessarily do that. And you can achieve the same thing in React, right? And now the other thing about the event loop is it's not necessarily an infinite loop because it runs until the event of completion. So if you have multiple events, right? Say calling this API or reading from this database, right? If you have all of them lined up and the event loop has processed each and every one of those, then there's no need to keep it running. There's no need to keep running. It terminates itself. Or you can manually stop the execution of of an event loop, right, is it's not necessarily an infinite loop, but it does support long running processes, right? And I'll talk a bit about that later on. But yeah, but that's really the beauty of the event loop is it's a very, 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 very potent piece of software. It's a very important artifact, right? So if you want more power in your event loop, essentially, if you want to be able to handle more than 1024 file descriptors, then you're going to have to plug in a PHP extension. You're going to have to embellish the language. Right? So one of either exduv, exduv, or exdevent will suffice, right? And ReactPHP takes care of the abstraction. So you don't necessarily need to write, EV, UV, and libevent handlers, right? Which are the libraries of these extensions respectively wrap around, right? So exdev is particularly interesting because it wraps around the select function, if you're familiar with low-level stuff, and UV is has an inbuilt queuing mechanism and is really performant and is very easy to embed. Like I said, Node.js has a libuv component, and so does Python's Twisted and Ruby's Event Machine, right? So you might want to check those out if you're trying to achieve non-blocking I/O. Really, if you're trying to write code, in accordance with the event style, the event-driven style in Python and Ruby respectively, right? Yeah, and you can install these extensions via PECL, right? So, how do you convey data in an event-driven system, right? Usually as a stream. And what a stream is, there's a stream abstraction available to users of React. What a stream is basically, it's basically data, a chunk of data made available over time, and data that is processed in a manner akin to items that items that are conveyed on a conveyor belt, right? So if you're familiar with if you've been to airport terminals, anywhere you've seen a conveyor belt, that's essentially that's a great analogy for how stream data is effectively handled. It's typically unbuffered, so there's no transient storage. There's no intermediate storage of stream data. So that makes it great for pipeline execution. So you essentially have one data pipeline, which is standard input. You can pipe it into standard output. You could have a duplex like TCP. I'll cover this shortly, which essentially has the capabilities of both readable and writable events. And essentially, you can make all your data flow from one end to another. So yeah, it's a lot like water, like the flow of water. Yeah, so you have readable streams, which are similar to the read events, the readable read events from previous slides, like standard input. You can get data from standard input, and the snippet on the right displays how to use the readable resource stream object to essentially read data from standard input and convey it. Just print it out onto standard, print it out onto the screen, but really to standard output, there's a better way to do it, right? Which would involve using a writable stream, right? So remember when I talked about piping, basically, connecting one stream to another, right? Creating essentially, what would be one channel stream data to another channel stream data. You can do that with standard output. This is a better way to convey data from standard input. Now, a lot of the examples in my slides are readily pluggable. So you can readily pluggable into your code. So you can actually copy paste this stuff and see the results. Here's all. So yeah, I'm hoping everybody has a computer, mounted on their desk or, whatever, and can, play around with this stuff. It's pretty interesting. And then you have, duplex streams that have the capabilities of both readable and writable streams, right? Like TCP/IP, or like a file that is opened in, read-write mode, right? So yeah, that's pretty much what the TLDR, the streams is, again, a chunk of data made available over time. That you can, streams are, these, streams are essentially just data that is unbuffered, right? That you can pipe from, essentially one channel to another, right? That's the TLDR. Really. Now, what about data propagation and action chains? What about essentially doing stuff with the data, right? In an asynchronous system? Well, you'll probably need promises for that, right? And there's a nice promise library, that is, the nice promise library maintained by the folks over at ReactPHP, right? Now, what is a promise? A promise, well, a more technical definition of promise is, well, it's a proxy mechanism for handling, undetermined data, right? But it's essentially a placeholder for, for this data, for said data, is for values that are yet to be computed, right? And promises possess a two-track anatomy. They have a two-track structure. So you have the data you intend to propagate, which is the data you want most of the time, which is in the resolve path, and then the data you don't really want, which you typically replace with some kind of exception in an asynchronous programming flow in the reject path. You put that in the reject path, right? And the beautiful thing about this two-track structure is, you can essentially you can essentially create some kind of railway pattern. If you're familiar with the work of Scott Lochemem, he's an F# advocate. It's a bit more functional programming related, but essentially promises, because they allow for forward function chaining. Again, whenever you're chaining, you're composing, and whenever you're propagating data inside of this resolve path, you're usually chaining it. So promises are, can be considered algebraic data structures for that reason. And promises allow you to write these two-track functions where you can handle both the positive, the stuff you want to resolve, and the negative stuff that you want to reject, right? So promises are really, really, important in that regard. And now I guess we should move to something more practical, something you can actually play around with. Now, I'm going to preface this part of the talk by saying that, yes, there's practical stuff here because I have a TCP connection open, and hey man, Murphy's Law. So if something's about to fail, and most likely will, so please bear with me. But yeah, let's move on to something practical, like a simple socket powered chat. Now, I wrote a simple chat you can access via Telnet. If you have Telnet protocol, you can try to connect to this we call it, to my TCP server, which is available at this address, 6.tcp.ngrok.io at the very bottom. Or you can, if you don't have Telnet installed, you can actually use the code, replace the address and the port portions in the snippet to essentially to create a client that you can use to access my TCP server. But sockets, when you're talking about sockets, well, you're talking about single endpoint in a two-way communication link, right? In between programs on some kind of network, right? And sockets are because of that suitable for network communications, right? And they're useful in client server setups. So what you typically have, like in this this case of this chat, for instance, is I have a socket server which is set up to run on a certain port, and then multiple clients like the ones that you've either implemented on your own with PHP code, on the slide, or that you're actually using telling it to approximate to access the resources on the server, right? So in this case, I've created a long-running process that allows you to communicate, send messages back and forth, right? So if you've connected to that TCP, I don't know if it's active right now, but if you've connected to that, then you probably received a prompt to enter your name and then to key in messages. So that's pretty much what it is. You can write a very, very basic chat, and like I said earlier, is the data in a TCP/IP connection is a duplex stream, so readable and writable. So you can essentially, read data, conveyed in TCP/IP socket, and write data. So the read portion is essentially everything you're seeing from every other client that is connected, right? And then the write portion, essentially the messages that you're able to send, right? So the duplex nature of those kinds of streams. So please connect to my TCP server and post a few messages. Nothing incendiary though. Don't do anything crazy there, right? Moving on. Because you probably now know a thing or two about sockets, is it's possible to set up an HTTP server without Apache bindings, without Nginx bindings. Well, as far as like just serving PHP files is concerned, you can use Nginx for a bunch of other purposes. But yeah, you can eliminate that Apache, that tier, and essentially provision an HTTP server with idiomatic PHP, right? And for that, you'll need the HTTP package that was built by the folks over at React. Right? Now, this is written in pure PHP, right? Again, the embellishments will help. So if you have EV or UV running somewhere in the background, is that type of thing will help. All this code is PSR compliant. It's reliably fast, right? And it has multiple integrations with a bunch of PHP packages, right? So setting up an HTTP server shouldn't be too hard. It's a lot like setting up an HTTP server in Node.js, right? Only, you're writing it in PHP, right? Yeah. So yeah. Now, essentially, how this is connected to the socket implementation that I just talked about is, because sockets are just one endpoint, this two-way communication link is you can bind a server to create a socket, bind a server to a certain port, right? For clients to access, right? That's essentially what it is. Right? So yeah, which is why you have a socket server and the bindings, the port bindings. Yeah, that's pretty much what it is. And then you can access your server with a very simple client. Again, with the React HTTP package, which is promise driven, so it looks a lot like JavaScript's fetch. You can actually write a function that mimics the look and feel of JavaScript's fetch in PHP, but it's promise based, so the resemblances is there. The resemblances are there. Pretty easy to use. Simply, pull that, get, post, patch, delete. All kinds of all manner of HTTP verb. It's compatible with this, and like the server, the client is PSR compliant, right? So yeah, you shouldn't have the tour time using this. Now, if you don't want to write your server in React, like just plain React, is you can use something like Framework X, right? which is something that the folks over at Cool Engineering have developed and will continue to maintain. So when I think about Framework X, I think about Express, right? It's a nice, it's a neat micro framework that wraps around ReactPHP. So if ReactPHP is what approximates Node.js, then Framework X is pretty much Framework X is pretty much the express is expressed to ReactPHP that it's pretty much akin to Express. I'm sorry, I just messed up the phrasing there, but you get the idea. Is Framework X is a lot like Express. So if you understand the Express Node.js relationship, then you definitely understand the Framework X ReactPHP relationship. So you can use this to process all kinds of data, JSON, CSV, XML, run this in any environment, even with those that have Apache bindings, right? And you can go from rapid application development to production in just a matter of minutes, because it's really easy to set up and really easy to integrate into your development environment, right? Another framework similar to Framework X, only this one's more macro, more components and whatnot, more bloat, is Driftphe, which is basically Symfony and React, right? This is maintained by Mark Morera, and it is essentially just an asynchronous wrapper. It's basically an asynchronous version of Symfony, right? So if you are familiar with the Symfony framework, then you can easily plug Driftphe into your application. So I ask that you try it out. Give Mark a shout for this work. I think it's good work. You can write a bunch of promise-driven controllers, return all manner of responses, JSON, XML, that type of thing. So Driftphe is certainly a piece of software I recommend that you consider using if you don't want to write something in idiomatic React, right? So you've probably written a bunch of non-blocking code, and you don't see a way to and you, for some reason, whatever reason, want to run your blocking code in an event-driven system, right? Which is typically a no-no. Like, you don't mix blocking and non-blocking code. It's just not. I mean, you have two paradigms that are just antipodes of each other, right? You don't necessarily want to meld blocking and non-blocking code, but there's a way. I recently created a package called Asynchrony that allows you to combine your non-blocking code with your blocking code, right? So things like routines like file get contents, right? Routines like file put contents are can be turned into asynchronous processes, and it can be rendered event-driven affable by using Asynchrony, right? So what does it do is it works on many non-blocking functions, essentially works on many blocking functions and just turns them into non-blocking functions. And this uses child process IO. If you're familiar with child processes, you'll know that they are an asynchronous solution to, asynchronous implementation of multiprocessing. So Node.js has child processes, and so does React. So I just use the child process module, and I wrote a wrapper around it to allow you to run your non-blocking code in the child process, your blocking code in the child process. So this library supports functional programming and traditional OO approaches. This is the code example on the right side of the screen. Demonstrates the FP approach, but you can use a more traditional approach with static methods and regular public methods and classes and all that. I like this because of, because of freedom that comes with, just shuttling functions around. I really like to do that. If you look at the code that I write in real life, it's just functions, really. So yeah, you can plug this into your code anytime, right? Now, what about applications that run in the console? Because those matter too, right? Applications that run in console are also considered user-facing software. Now, React has got you covered. Again, you can write simple REPLs, read, evaluate, print, loop type software in React with Christian's SCIO, standard input output React, right? So much like regular applications that you serve over HTTP or over TCP/IP, is console applications can benefit from from the potencies, the many potencies of non-blocking IO, asynchronous IO, or event-driven IO. And so I ask that you consider using this to build your REPLs. I wrote the shell for my functional programming library in React with Christian's SCIO React program. I think I'll probably link that somewhere. But yeah, but you can build shells, console applications as well with with React. Now, before I conclude, I want to mention that ReactPHP has a very vibrant ecosystem. And you can check out the ReactPHP wiki to find all the packages available. All the packages built atop React PHP that are available to the to people interested in using plugging React PHP into their applications, right? Basically available to the public. This ecosystem is growing. There's more and more packages being released on a regular basis, as well as updates for already existing packages that are being released on a regular basis. I spoke briefly about the new default loop, which is one of those updates, one of those major updates. So you don't have to, call the static method and then invoke the run, the public method at the end of your script, your entry script. You don't have to do that anymore. So there's that. So if you're looking for additional material, if you want to learn more about React, you can check out the official documentation. You can check out an article that I wrote for PHP Architect, and you can check out Sergey Zook's book, Learning Event-Driven Programming in PHP, and entries in Sergey's blog and YouTube channel, right? And before I leave, I'll ask you kindly to give Asynchronous PhD a try. You likely won't regret it, right? So you could write a simple REST API, right? That's one of the ideas. You could write a simple shell, or just write a very basic asynchronous IO script, right? Like the ones that I've shown, the ones that are in the slides, right? So that concludes my talk. Thank you so much for tuning in, for following. If you've made it this far, there's a lot of React, a lot of asynchronous this and that, and again, thank you to thank the organizers for accepting my proposal. I'm really passionate about this stuff, and you can ask me any questions. I shared links to my my website, my Twitter handle, my GitHub handle. If you want to collaborate, if you have any questions. Oh, also there's a Discord chat where you can post any ideas about any ideas you might have related to this talk, related to this topic, right? So yeah, just thank you so much. I hope you guys are able to actually connect to the socket powered chat. I hope the TCP connection actually worked for you. And yeah, that's pretty much it. That's my talk on asynchronous programming in PHP. Right. Please give it a try.